The Move command is very important when modeling with PYTHA. This video about Move builds on the videos about the block and delete. The part selection is explained in detail there. The workflow for Move is the same as for delete. Open the Part Tools 1 menu either via this icon or via the Part Tools 1 button in the vertical menu. Activate the Move command. The input prompt appears and asks which parts you want to move. If you would like to learn more about the selection options, take a look at the tutorial Delete and Part Selection. I select the block here at the front with a left click and confirm the selection with the middle mouse button. A little tip at this point. If you know that you only want to select one part, as here, you can also select it directly with the middle mouse button. The respective part is then both selected and confirmed with this click. This eliminates one work step. After you have confirmed the part selection, you must specify where you want to move, and so specify the direction and distance of the movement. There are various methods available for this, which I will now show you. Depending on the task, one or the other method may be more suitable. After you have confirmed the part selection with the middle mouse button, this multicolor symbol appears in the center of the selected parts. This is the Move Gizmo. We can use it to interactively move parts quick and easy. To do this, I left-click on the Gizmo. The selected parts now stick to my mouse cursor and can be moved to any position using the mouse. With the next left click, I drop the parts at the new position. The command ends automatically. I activate Move again in the vertical menu and select the block with a left click. I then confirm the selection with the middle mouse button. The gizmo appears. As just explained, we need to pick the gizmo with the left mouse button to move the part interactively. Here it is important where we pick the gizmo. I have just clicked on the gizmo at its center and then could move the part completely freely in the base plane. If I click on one of the arrows, the part will only move in this direction. If I left-click on the red arrow, for example, the part will only move parallel to the red x-axis, no matter where I move the mouse. As already explained for delete, you can cancel the command at any time by right-clicking. The part then flies back to its starting point. You can also combine the gizmo movement with a number input. It works like this. I activate the Move command again and select the block with the left mouse button. I confirm the selection with the middle mouse button and the gizmo appears. By left-clicking on the green arrow, I now restrict the movement to the y-axis and move the part roughly in the desired direction. Without pressing a mouse button, I enter 30 on the keyboard and press the Enter key. The part jumps to its destination and the command ends automatically. So we have just moved the part exactly 30 millimeters along the y-axis. I repeat the steps. And select the green arrow again. What is important now, before entering the value, is the direction in which the part is moved. If I move it in the positive axis direction, the numerical value is also applied in this direction. If, on the other hand, I move it in a negative direction, the value is applied in this direction. So I don't have to pay attention to a positive or negative sign when entering the number. It is the initial direction of movement that counts. But the gizmo can do even more. Once again, I activate Move, select the block and confirm the selection with the middle mouse button. You will have noticed that the gizmo not only has arrows, but also a blue circle. You can use this circle to rotate the part selection in the base plane. To do this, click on the circle with the left mouse button and interactively rotate the part in the desired direction. Another left click places it at the current angle. PYTHA also has its own command for rotating parts in Part Tools 1 menu. This offers many more options. Think of the circle on the gizmo as a small shortcut for simple applications. The gizmo is still visible after rotating. The move command is therefore still active. You can now either use the other gizmo functions or end the command with a right click. Please always make sure that you pick the symbols of the gizmo in the right place. The mouse cursor always shows which mode the left click would activate. At the moment, this is the X direction. Have you noticed that PYTHA occasionally provides information on special functions in the input prompt? Here, for example, you can now find out that you can hide the gizmo by pressing the G key on the keyboard. Press the G key again to show it again. The second note on immediately drag is also useful. To use this function, do not pick the gizmo. First, hold down the Control key on the keyboard, then click on any point of the selected parts with the left mouse button as a guide point. I use this one, here at the front of the block. The picked guide point now sticks to the mouse cursor together with the part. If I move the mouse over the existing geometry, you can see how the guide point literally jumps to certain elements. This process is called snapping, and has the great advantage that objects can be placed with absolute precision, even though they are only guided interactively. The mouse cursor always shows what is currently being snapped to. At the moment, it is a point, now the center of the edge, and now the center of the face. By the way, I hold down the Control key all the time. That's why the block jumps to the other parts on its own. As soon as I release the Control key, my selected parts only move in the base plane. So much for moving with the gizmo. In many applications, you want to move parts by an exact value. As shown above, you could use Gizmo for this and enter a numerical value. But there is also a quicker way. Activate the Move tool and select your parts. This time, we will simply ignore the gizmo. The input prompt asks for the distance. dx, dy, dz shows us that the distance of the displacement must be entered, parallel to the x, y, and z axis. Strictly watch the order of input x, y, z. For example, if I want to move the selected block by 150 mm in the x direction, I enter 150 for the x direction, then (0) for the y direction, and (0) for the z direction. The zeros mean that no movement should take place in this direction. Press the Enter key to carry out the movement. If we now want to move the same block by 50 mm in the y direction, we enter 0. As this time no movement is to take place in the x direction, 50, 0, enter. And if we now want to move the block by 60 mm in the z direction, the input is 0, 0, 60. Yet, if the current position of the block is the target position, we do not have to perform the movement in individual steps, but can do it with a single input. Remember the current position of the block. I undo the last steps with the undo icon. I activate the Move command again, select the block with a left click, and confirm the selection with the middle mouse button. When asked for the distance, this time I enter 150, 50, 60. As soon as I press the Enter key, the block flies directly to its target position. Even if we don't see, it takes the path that we have previously carried out in individual steps. This allows you to visualize the value input. In most cases, however, you do not want to move parts in 3 directions, but only in 2 directions at the same time. For example, 90 mm to the side and 40 mm upwards. The input is then 90, 0, 40. And for a movement to the rear, which is parallel to the y-axis, 0, 90, 40. In the previous examples, we always moved the parts in the positive axis direction. So in my example, to the right, backwards and upwards. However, you can of course also move the parts in the opposite direction. To do this, simply enter a negative value. For example, if I enter the displacement for this block as 40, 0, 0, it will move 40 millimeters to the right. If, on the other hand, I enter minus 40, 0, 0 for the distance, the block moves to the left this time. In other words, in the opposite direction. However, a direction specification, to the left or to the right, is not clear. If I rotate the view of my project, the right side is now on the left and vice versa. If I now move the same block again with a positive value, for example with 40, 0, 0, this time it moves to the left and not to the right. But how can I tell when I need to enter a positive and when a negative value? Quite simply, by looking at the axis labels. If, for example, we have a look at the x-axis, we see a red line that starts at the 0 point and then runs to the left to the border of the window. At its end, you see the letter X. This letter always indicates the positive axis direction. So no matter how I rotate or move my view, the letter on the axis always shows me in which direction the positive axis direction runs. This means that whenever I want to move parts towards the letter, I enter a positive value. And whenever I want to move parts away from the letter, I enter a negative value. A little tip. Sometimes you will zoom in on details of the project and no longer see the coordinate axes. In this case, the small axis cross in the top corner will help you. As you can see, it rotates with my view and also always shows me the current axis directions. In this view, the small arrows symbolize the positive axis direction. There you go. Now you know how to move parts in PYTHA by entering values. However, we can shorten the inputs that we have learned a bit and thus become even faster. For example, you do not have to enter any zeros. If I want to move this block upwards by 60 millimeters, I would actually have to enter 0, 0, 60, so no movement in the x and y direction, and 60 millimeters in the z direction. But the input is sufficient, 60. I think of the zeros as a symbol for no movement, but don't enter them. PYTHA then knows automatically no value has been entered for x and y, so there should be no movement in this axis direction. Accordingly, a shorter input for movements in the y direction is 60, and here we can make another saving. Since there is no more information after the numerical value 60, we can also omit the comma. To move the part 60 millimeters in the positive y direction, the input 60 is enough. And for movements along the x-axis, it is even easier. No further information is entered after the x value. It is therefore sufficient to type the x value and press enter. Now you know how to move parts in PYTHA by entering values. At first, this input method may seem a bit complicated, but after a little practice, you will learn to appreciate the speed of this method. PYTHA offers yet another method for moving parts, the point-to-point method. This method is most commonly used when designing in PYTHA, as it is easy to align parts to existing geometry and the parts are placed exactly. As before, I start the Move command and then select the parts to be edited. As soon as I press the middle mouse button, the selection is confirmed and the input prompt asks for the distance. I now click directly on the corner point here at the front of the block with the left mouse button. This point thus becomes the guide point and serves as a reference for the movement. Now I click on the desired target point with the left mouse button. The previously explained snapping function is active again. This means that I can clearly see how the mouse cursor snaps to certain elements of the existing geometry. At the same time, the text on the mouse cursor shows me what is being snapped to. PYTHA recognizes points, edges, the center of edges and faces, the axes, auxiliary lines, the grid, and so on. I pick at the existing block, the point at the top here. Now PYTHA shows me the movement of the block as a preview. At the same time, a red arrow appears, symbolizing the picked distance. In addition, a small dialog box has opened, offering me several options. At first, however, I do not want to use these options and close the dialog with the Move 3D button. Whenever you want the picked guide point to lie exactly on the target point, use this button. I undo this step and repeat it in the same way. The first time I closed this dialog with the Move 3D button, the result was the movement as we see it now in the preview. If I click with the mouse cursor in the number field in front of X only, I see a new preview. Here too, PYTHA aligns the two picked points. But the block is now only moved along the X-axis. Alternatively, you can also move only a parallel to the Y or Z axis. Always click in the number field to left of the button to get a corresponding preview. As soon as you have found the desired direction of movement, close the dialog with the button next to the input field. I cancel the process and repeat it again in the top view, which is the XY view. By the way, when moving point to point, the gizmo sometimes gets in the way because it hides points that you want to pick. You would not pick the geometry point, but the gizmo. I mentioned earlier that you can hide the gizmo by pressing the G key on the keyboard. I'll do that now. So we have picked this point as the guide point and this as the target point. Again, the movement across the space is displayed as the first suggestion. The Z field of the dialog is greyed out because we cannot see this axis in the current view and therefore cannot pick it. I click again in the number fields to the left of the Only X and Only Y buttons to get a preview. Here in this view, we can see clearly how the block is moved along the selected axis so that the guide point is aligned with the target point. I press the Only Y button to place the block. By the way, if you already know in which direction you want to move, you don't need a preview. You don't have to click in the number field first, but can press the corresponding button directly. Let's play with these blocks a little more to become more familiar with this. If the current preview already corresponds to the desired movement, you can simply press the middle mouse button to confirm. You do not need to click an extra button in the dialog. But the little dialog not only offers us a useful preview of the result. What is much more important, you can overwrite numerical values. At the moment, they show me the exact distance between the two picked points. I can now simply overwrite these numbers with any other values. PYTHA then only uses my pick to give the direction, but the value I have entered by hand as the distance. And you can even enter any mathematical formulas in the number field. I repeat the same step again and add -10 to the picked value. Enter. PYTHA calculates the picked value -10 for us and then moves the part accordingly. As a result, we get a gap of 10 millimeters between the two blocks. I repeat the work steps once again. This time I pick this edge center as the guide point and this edge center as the target point. The value determined by PYTHA would make the two centers coincide. However, I intervene and type divided by 2 behind the number. I will show you the initial position of the block again for comparison. Now you can see that the new calculated position is exactly in the middle, as I have cut into half the picked numerical value. I admit that was quite a lot of information. But don't be afraid. Once you have become familiar with the input options for the block and moving, you will already have mastered the most important functions of the software. You will soon find out that the steps you have learned here are applied in similar ways in most of the other commands. I hope you enjoyed trying out the functions shown and look forward to seeing you again in my next PYTHA video tutorial.